Welcome to Mrs. Neller's notes for her double block algebra class. These are the notes for section 9.8 entitled Graphing Quadratic Inequalities. And today we're going to keep practicing graphing quadratics, except now they're going to be inequalities. So we're going to add a couple more steps to it. And then we have to determine if an ordered pair is a solution of an inequality. Now, remember when we were graphing quadratics, we had a couple steps that we had to follow. The very first thing we wanted to do was we wanted to make sure that the quadratic was written in descending order so we could do our negative b over 2a equation to find our axis of symmetry. And then that is the value that we put in the middle of our table, and we picked two values above it and two values below it to complete our table. Substitute all those values in for x, get our y values, and then we can plot the points. So usually there's 5 points that you're plotting for your parabola. Okay? So we're still going to do those same steps today, and we're also going to use a dashed or a solid line to connect our points, and then we have to shade either above or below, but now it's kind of like inside or outside the parabola. So what was above and below is now going to be inside or outside the parabola. Okay? We don't really need that third point there. So we're going to graph the way that we did in the previous section of notes, and then we're just going to add on these two steps. And these are the two steps that we've done before when we've graphed linear inequalities. Okay, so let's take a look at 3 graphs. Okay, for part A here, I have y is less than x squared minus 4. And it's written in descending order already. If you want to add in your x term, you could add in your a term here too. 1x squared plus 0x minus 4. That would be the way to completely write the whole quadratic so that you have your a term and your b term and your c term. Remember, a is 1, b is 0, c is going to be the negative 4. Now we need that so we can do our negative b over 2a. So that would be negative 0 over 2 times 1. Doesn't matter what's in the denominator there because our answer is just going to be 0. So that's our axis of symmetry. That's the middle of our parabola. So we're going to put that value in the middle of our table and then pick 2 values above it and 2 values below it. Then we're going to substitute each of these into our equation here. So 2 squared is 4, minus 4 is 0. 1 squared is 1, minus 4 is negative 3. 0 squared is 0, minus 4 is negative 4. And then negative 1 squared is 1, minus 4 is negative 3. Negative 2 squared, remember it's negative 2 times negative 2, so it's a positive 4, minus 4 is 0. Now notice again that we get this pattern here in the right-hand column, in that y column. That's good if that happens, okay? So then we have to graph it. So 2, 0, 1, negative 3, 0, negative 4, and then negative 1, negative 3, 2, 0. Okay? Now yesterday, or in the previous section of notes, we just connected these points, made our parabola, double checked that it was opening the correct way. Notice A is positive, so this parabola will be opening up. So that's good. Okay? But today we got to add in those extra steps. We have to take a look at our inequality sign. We have a less than as our inequality sign. Now when it's just less than or just greater than, we connect our points with a dashed line. We need that equal to in order to make a solid line. Now, usually what we do after that is we shade either above or below the line. Okay? Now, that's what we do when we have a straight line. So you need to kind of visualize here. Pretend that this parabola is like a piece of string, and you're going to grab the little arrows, and you're going to straighten out this parabola so that it would be a straight line, a straight horizontal line. And then if this is less than, we would shade below. So we would want to shade below that horizontal line. But then if you took your string and you wrapped it back up so it formed that parabola again, all that stuff that we had shaded below would now be on the outside of the parabola. So we'll visualize that in class too. We might even have some string that we bring in to use. So if you want a piece of string, you can try that. Okay. But really, once you try it a couple times, you get a good sense for how to visualize it and how to shade. Okay, let's try part B then. Now part B is already written in descending order. We've got our negative 2x squared minus 4x plus 3. So it's already in descending order. I've got my A value, my B value, and my C value. That's good. So now I just need to do the negative B. So that's a negative 4, so that's positive 4, over 2 times A, so that's 2 times negative 2. So that's going to be 4 over negative 4, so that's going to be negative 1. So negative 1 is where I'm going to start my table. And then I'm going to pick 2 values above it and 2 values below it. And then those values I have to substitute in for the x's. So I have to do negative 3 squared is 9, times 2 is negative 18. And then negative 3 times negative 4, that's positive 12. So negative 18 plus 12 is negative 6, plus 3 is negative 3. So again, if you're doing this substitution by hand, this can be a little time consuming. We can show you how to do this on the graphing calculator, so it'll do all this substitution and making the table for you. When you substitute in the negative 2, you should get a 3. When you substitute in the negative 1, you should get 5. And then our pattern is going to repeat. So again, in this right-hand column here of your table, these y values, you should get a nice pattern that repeats. Usually the only time you don't get that is when you have a fractional vertex. So in the notes that we did for 9.4, we didn't see that pattern as often because we had some fractional vertices. Okay, but now I'm ready to graph. So negative 3, 1, 2, negative 3. And then negative 2, 1, 2, 3. Negative 1, 5. And then 0, negative 3, and 1, negative 3. Oops, that's negative 4. There we go, negative 3. Okay, now again, I have to look at my inequality sign to figure out what kind of a line I'm going to make. That has the equal to, so I'm going to make this a solid parabola, solid line. And it's opening down, and that's good because our A value is negative, so it's supposed to be opening down. And now I just need to figure out where I'm going to shade. So again, think of the ends of the parabola as like ends of string that you can pull out in both directions and make it a nice horizontal line. This is less than, so that means I would shade below that horizontal line. But then if I pulled the ends of the parabola back down to make it curved, all that stuff that I shaded below would now be inside the parabola. Okay, so you have an example now for shading outside and inside the parabola. One that opens up and one that opens down. Okay, now you can also have a parabola that opens down and you shade outside. And you can also have one that opens up and you can shade inside. So there's really 4 different types of parabolas that you can get here when you graph them and shade with the inequalities. Okay, so let's look at example 2 now. Again, we're going to make another graph, and then we're going to plot this point and decide if the point is inside or outside the parabola. Okay, so this is kind of practicing our graphing again, and then it's setting us up for what we're going to do in example number 3. Okay, so to start this problem then, we're going to start it just like we did the last one. We're going to take a look just at our equation here. So the way it's written, this ordered pair we're going to save until later. So it's already in descending order. I've got my 1x squared minus 2x plus 5. So that tells me my a value is going to be the 1, my b value is going to be the negative 2, and my c value is going to be the 5. So then I'll do my negative b, so negative negative 2, that's a positive 2, over 2 times a, that's a 1. So 2 over 2, that's going to be 1 altogether for my axis of symmetry. I have x and y, so I'm going to start my table at 1, pick 2 values above it and 2 values below it, and then I have to substitute. So remember, when you substitute in the negative number and you square it, a negative times a negative is a positive. And then here you have a negative 2 times a negative 1, so that's another positive. So we're going to end up with 8, and then we'll get 5, and then we'll get 4, and then the pattern's going to repeat itself. Okay. So again, remember, this is my vertex here, the 1, 4. That's going to be the middle of my parabola. Okay, so negative 1, 8. It's right up there. 0, 5. And then 1, 4. And then it repeats. So 2, 5. And 3, 8. So use that symmetry to help you plot the points. And this is an equation now, so I can just make a solid line. I don't have to worry about shading on this one because it wasn't an inequality. But I do have to plot that point then, that 0, 4. So 0, 4, 0, 1, 2, 3. Oh, it's really close, but 1, 4 is right there. Okay, and it says to determine if that point is inside or outside the parabola. Well, this, in order to be inside it, would have to be inside the little bowl that's opening up. So this would be on the outside then. Okay. And this kind of leads us into our next example where we're going to do this with an inequality. So we're going to determine if the inequality is a solution to, or I'm sorry, if the ordered pair is a solution to the inequality. And again, you could graph this and you could see if the point was inside or outside the parabola, if it was in or outside that shaded region. But we could also do this just by substituting. So remember, the 3 is our x and the 4 is our y in our ordered pair. So I can substitute those values right into our inequality. So 3 squared minus 5 times 3 plus 3. So then I'm going to simplify the right side of the inequality and see if it is a true statement when I get all the way done. So 3 squared is 9, and 9 times 2 is 18. 5 times 3 is 15, and then plus 3. So that's all gonna reduce down to 6. So 4 is greater than or equal to 6. No, that's not a true statement. So that means if I did actually graph this parabola, I'd have to make my table of values, and I'd have to have a solid line. And I think the parabola would open up, and it's going to be greater than, so we would shade inside of it. And then our ordered pair 3, 4 ends up actually being outside the parabola. So the shaded region, remember, that's where our solutions are. So if this ordered pair is outside that shaded region, it means that no, it's not a solution. Okay? So we could graph it and we could get our answer that way too, or we could do the work algebraically. Okay? So tonight's homework is mostly focusing on graphing the inequalities, and then they're going to have a few of those problems where they want you to extend it to whether or not an ordered pair is a solution, if it's in the shaded region or it's not in the shaded region. So make sure you have graph paper, show your work, make those tables of values, and if you have questions, come on in and see us before school.